All right, welcome to the Explainer. Today, we're going to dive into a core concept in computer science that, believe it or not, you already use every single day, probably without even thinking about it. We're talking about the queue. You know that feeling, waiting for your morning coffee, standing in line for a movie? Well, that simple, everyday act of lining up, that is the perfect real-world model for the entire data structure we're going to break down today. So what exactly is a queue when we talk about programming? Honestly, it's pretty much what it sounds like. It's a digital line. It's this incredibly useful way to organize data or tasks or requests right in the order they showed up, which ensures everything is fair and orderly. And this right here is the golden rule. It's the one thing you have to remember. The first person to get in that line is the first person to get their coffee. It's the same with data. The first piece of information to enter the queue is the first piece of information to get processed. It's simple, it's fair, and it's incredibly powerful. Okay, so how does this digital line actually work under the hood? It really all comes down to one simple, absolutely unbreakable principle. That core principle is called FIFO. You're going to see this acronym everywhere, and it just stands for first in, first out. It's easy, right? Just think of the front of the queue as the cashier and the rear as the very, very end of the line. New things can only join at the back, and they can only leave from the front. That's it. Let's just watch this happen. So a new item gets added or inserted. Where does it go? Always to the back. The queue then updates what it calls its rear pointer, which is really just a little marker that keeps track of the last item and points it to this new position. It's exactly like someone getting in line right behind you. And getting something out of the queue, just as straightforward. We always take the item from the front. Once it's gone, that front pointer just scoots over to the next item in line. The line gets a little shorter, and the next piece of data is up. So this sounds great in theory, but how do we actually build one in code? Well, the most direct way is to use a structure you might already be familiar with, an array. You can just think of an array as a long container with a fixed number of slots. We use those slots to hold our items. It's simple and it works. But, and this is a big but, it has a pretty nasty hidden flaw. And that hidden flaw, man, it leads to a really inefficient, kind of frustrating problem. Because while using an array seems perfect at first, it can end up wasting a ton of valuable memory. I want you to picture this, right? We've been adding items, removing items, things are going great. Our line is moving. But what happens when our rear pointer, the one tracking the back of the line, hits the very last slot in our array? And this is where things get weird. Even if we've removed a bunch of items from the front, leaving all these empty, usable slots, the queue just thinks it's full. The rear pointer can't move any further, so it just says, nope, sorry, we're full. All that empty space is just sitting there, completely wasted. So we get stuck in this ridiculous paradox. The program is telling us the queue is full, but we can literally see the empty spots right there at the front. This is a massive inefficiency, and, well, it needs a solution. Thankfully, some very clever computer scientists came up with a brilliantly simple and, frankly, elegant solution to this whole wasted space problem, and it's called a circular queue. So instead of thinking of our array as a straight line, I want you to imagine we connect the very end right back to the beginning, forming a circle, or a ring. Now, when that rear pointer hits the last slot, it doesn't just stop. It cleverly wraps around to the first slot, ready to use any of that empty space we created earlier. It's so smart. And you know, the fix in the code is surprisingly simple. With a normal linear queue, when the rear marker hits the end, that's it. Game over, queue's full. But with a circular queue, we just add one tiny rule. If the rear marker hits the end, instead of stopping, it just wraps around and resets to the beginning. It is a tiny change in logic with a huge impact on efficiency. And guess what? The same wraparound logic applies when we remove items. The front pointer also loops back to the start after it reaches the end. This one simple trick lets us continuously use and reuse every single slot in our container, which completely eliminates that wasted space problem. Okay, so we've totally geeked out on how they work, but let's take a step back for a second. Why does any of this matter? Well, because queues are really the unsung heroes of computing. They're silently managing everything behind the scenes, bringing a sense of order and fairness to otherwise chaotic systems.
I mean, they're everywhere. When you send a bunch of documents to a printer, a queue manages those print jobs to make sure they print in the right order. When you're streaming a video, a queue is handling all the network data packets to prevent it from becoming a jumbled mess. Every single one of your mouse clicks and keyboard presses, a queue is processing those in sequence. Queues are the invisible force making sure things happen when and how they're supposed to. Ultimately, when you boil it all down, queues bring fairness to digital processes with that one simple rule: first come, first served. So the final question is, in a world full of complex algorithms and systems, where else could this simple, predictable idea of fairness, where else could the first in, first out rule be a total game changer?